Hi, welcome to a lesson about primes. So the last topic on these slides is determining whether a number is prime or not. So I'm going to take an example to explain, and we're going to look at 703. Now, if I went by the definition to figure out whether it's prime, I would need to divide it by 2, 3, 4, 5, 6, 7, 8, 107, 191, 201, every single natural number from 2 to 702. And that would get really old fast. So we want to see if we can do this more efficiently. So we're going to do two things. One thing is I don't really have to look at every number. I can just look at the primes. So for example, if 6 divided 703, then 2 would and 3 would because I could factor that 6 factor into a 2 and a 3. So we only have to consider the primes less than 703 and figure out whether they divide 703 or not. The second way we can make this faster is that we don't have to go all the way up to 702. We only have to go up to the square root of this number, 703. Because if I took two numbers and both of them were bigger than the square root, when I multiplied them together, I'd get something more than 703, and that's too big. So one of the factors has to be bigger than the square root, one has to be smaller, and we'd catch the smaller one if we only look at primes less than the square root. So let's see how we do this. So we have to start by thinking about the square root of 703, and I don't know what the square root of 703 is off the top of my head. So I'm going to pick something to be safe, a little bigger, or actually maybe a fair amount bigger. I chose 900 because I know that that's 30 times 30. So it's a number whose square root I know that's a little bigger. If it's a lot bigger, all that means is I'm going to do a bit of extra checking. So I'm going to take all the primes less than 30, and I've written them down near the bottom of the slide. It's 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. And in class, we'll figure out what the list looks like of all the primes that are less than 100. That'll tell us what numbers are prime that are less than, what, 1,000. So, or 10,000, yeah. So we have divisibility tests for 2, 3, 5, 7, and 11 from the last lecture. You should check whether 703 is divisible by 2, 3, 5, 7, and 11. So please stop the slides and see what the result is when you try to divide 703 by each of those. Are they divisible or not? Okay, so you're back, and I don't think 2, 3, 5, or 11 are going to divide 703. So let's look at the numbers on the list that are left. There's 7, 13, 17, and 19. So I could try to divide 703 by 7. I know 703 is 700, which definitely 7 divides, plus 3 more, and I know the 3 part is not divisible by 7, so 7 does not divide 703. We'd have 3 left over. If I try to divide by 13, you could get out a piece of paper and figure this one out if you like. Or let's say you could divide it into, what, 650 and 53? The remainder is going to be 1, right? 13 goes into 650 evenly, and then I would have left 53. 13 times 4 is 52 because I play cards a lot, and there's 4 suits with 13 in a suit. And so 13 doesn't divide 7, though 3 is the takeaway. If I divide by 17, I could do it by reasoning it out. You get 6. But if you divide by 19, guess what happens? It goes in perfectly. There's no remainder. 19 divides 703, and 703 is not a prime number. And if I want to factor it, now I know what one side is going to be on my factor tree. I'll have a 19 on one branch, and you can divide to find out what the other one is. I think it's 23. So let's do some more. You tell me whether or not 391 is a prime. So please stop the slide, give it a try, and when you're ready, we'll check your answers. Okay, so I hope you really did this. So 391, it's almost 400, right? And 400 is 20 times 20. So I'm going to look at the primes that are less than 20. And we have tests for 2, 3, 5, and 11. I do those divisibility tests. They all fail. So now I really have to look at 13, 17, 19, and 7. If even one of them divides, we stop and we're done. So I divided 391. I want to know if it divides by 7. I split it into a sum of 350. 7 goes into that. And 41. 7 doesn't go into that. So 7 doesn't divide 391. And 391, that's 390 and 1. 390 is definitely divisible by 13. And there's 1 left over. So no go for 13. But if you try to divide by 17, it actually works. And I guess this one was the 23. So the last slide, it was not 23. You'd have to go look it up. Sorry about that. You can fix it. So one more. You do 337 all by yourself. So again, shut off the slides, give it a try, figure out whether 337 is a prime or not. 337 actually is prime. You should have checked the primes from 2 to 17. You have divisibility tests for 2, 3, 5, and 11. And there's various ways you can check that 7 doesn't work, 13 doesn't work, 17 doesn't work. So 337 is a prime number.